If prompt changes still ship because they looked fine in a few manual tests, you do not have an eval system. I'll use Promptfoo to compare variants and failed bad changes before deploying. This is the pattern you'll be able to implement by the end, which scores prompt and model outputs and blocks changes that miss the quality bar. I'm Professor Pi, teaching AI engineering and LLM systems with simple Python. We ship prompt changes more often than we test them. That creates regressions you only spot in production. Promptfoo CI Eval Gates solve that by running reproducible, machine-readable checks on prompt and model outputs inside your continuous integration. Success looks like catching a bad wording change before it costs tokens or user trust. This setup works well at small and medium scale, where deterministic providers or canned examples let you write tight assertions and get reliable pass rates fast. At a high level, the idea is simple. Run a controlled evaluation, compare baseline and candidate behavior, and fail the build when quality drops. You get a numeric signal you can tune. Strengths are low friction and clear rollback criteria. Weaknesses are that you must design representative tests and be careful not to gate exploratory research too tightly. We will build a tiny, deterministic pipeline that verifies the Promptfoo tool, runs a sanity evaluation, compares two prompt variants, applies a normalization tweak, and then enforces a CI gate. The code uses the echo provider so outputs are predictable, YAML configuration for cases, and a small Python wrapper to call Promptfoo and interpret JSON output. No heavy ML here, just solid engineering to protect your prompt service. First, let us verify the CLI is reachable. This snippet verifies that the Promptfoo CLI is installed and reachable by invoking its version command. It sets the variable pf to the executable name and uses subprocess run to call Promptfoo version, capturing standard output and error. The variable s concatenates both streams to robustly handle environments where the tool prints version info to either channel. A regular expression searches for a semantic version pattern, and the code extracts it into ver, or returns unknown if not found. The single print displays the detected version. Seeing a concrete version confirms your tooling baseline, which is a prerequisite for reproducible CI runs. Next, we run a minimal deterministic check to make sure evaluations work. This example runs a minimal Promptfoo evaluation using the echo provider, so results are deterministic. The string CFG holds a compact YAML with one prompt and two tests that assert each output contains the input variable Q. A temporary file is created and written for the Promptfoo CLI to consume. The subprocess run call invokes Promptfoo eval with output set to JSON to make the run machine friendly, and we read the return code as a coarse pass or fail signal. The variable rate is set to 1.0 if all assertions passed, otherwise 0.0. The printed pass rate shows a quick sanity check that your evaluation pipeline is wired up. Now we compare two prompt variants and pick the better one by a simple metric. This code compares two prompt variants using Promptfoo to execute the run, then ranks them by average output length. The CFG2 YAML defines the echo provider, two prompts, and two simple tests to exercise both prompts. A temporary file is written and passed to Promptfoo eval, keeping the workflow reproducible. Because the echo provider mirrors the prompt text with variables filled, L0 and L1 compute average character lengths for explain and short variants. The variable best selects the shorter option, which is often preferable for latency and cost. The printed best prompt and average len gap quantify a concrete, measurable change between prompt choices. Next, we apply a normalization step to make scoring more robust. This snippet runs a Promptfoo evaluation with the echo provider, and then applies a normalization tweak that improves scoring robustness. The CFG3 YAML creates deterministic outputs like answer:"hi" and answer:"hello, which are easy to post-process. The list preds mirrors outputs, while gold contains desired lowercase tokens. The Boolean norm controls whether comparisons use p-lower or the raw string, making the normalization explicit and adjustable. Increasing normalization breadth, for example trimming or punctuation removal, can further raise accuracy at small additional CPU cost. The printed normalized pass rate confirms the metric gain from a pragmatic, controlled text transformation. Finally, we convert the comparison into a gate that blocks bad changes. This example turns comparison into a CI-ready gate by running Promptfoo and enforcing a simple regression rule. The CFG4 YAML includes both baseline and candidate prompts under the echo provider, so outputs are deterministic. After invoking Promptfoo Eval, the code computes baseline and candidate average lengths, then sets block to true if the candidate is longer. You can replace length with an accuracy or rubric score parsed from Promptfoo's JSON to gate on quality directly. Tightening the rule increases protection, but may block beneficial exploratory changes. Loosening it reduces friction at the risk of regressions. The printed CI blocked flag shows whether the change would be stopped in CI. To map this toy workflow to a real project, run the same steps against a representative test corpus and parse real rubric scores instead of length. Use the same gate logic in your CI job and fail the build when the score drops. Recap: Promptfoo CI Eval Gates is a lightweight pattern that runs deterministic evaluations, scores outputs, and enforces a regression rule. Use it when prompt changes touch user-facing behavior or cost. One caveat is test design. Your checks must reflect real user expectations, or they will either overblock or underprotect. For a next step, tune the gating threshold or swap the length metric for an accuracy rubric, so the gate enforces real quality instead of token count. If practical AI engineering helps, subscribe and watch the AI engineering videos.